Hi everyone. So this is the second dry run of the South Florida ISSA talk that I'm going to be giving. And I wanted to talk a little bit about some of the things that we've been thinking about at Immunity very recently in terms of how is the modern internet cybersecurity technology process working. So I called it a journey of discovery because I wanted to look at where our thoughts were going as we sort of got absorbed into a bigger company is one thing, and then also looked at bigger problems. And then, as the foreshadowing has indicated, this is who I am for those people who've never met me before. I worked briefly for the National Security Agency. It's one of those things you really never get off your resume. Then in 2001 started Immunity. Immunity then was a business that I ran for 16 or so years until we recently were acquired by Sixterra, based here in Miami, which is a very large hosting provider, but also has a very large security business built into it. And then probably the reason that most people know me is that for that entire time I've run this mailing list called Daily Dave, which has a number of security people. It's really not daily, and it's not about me. It is really about, so before blogs, people needed a place to talk about stuff and talk about their products and their exploits. And so it's a very technical list that of course you're welcome to subscribe to. So one of the things that we've been thinking about pretty heavily, a lot of us play Overwatch or other video games that have the same structure, and you can be a number of different characters, and each of those characters is kind of good a little bit against another character. So you're kind of playing a big game of rock, paper, scissors, plus you get to shoot stuff. And some characters are good against nobody, like Mercy is good against nobody. It's not really true. And one of the things we've noticed is that every time they release a new patch for these games, you go through and you try to figure out which characters match up better now based on other characters. And there's a little bit of a intuition to it, and then people tend to disagree about it. But the weird thing is you'll see that certain teams will figure out a strategy based around a set of characters, and then that strategy will be something other teams won't be able to adapt to. And the most recent one is called Goats. There's a team called Goats that realized that you didn't need any damage dealing characters at all, and you were basically unstoppable. And so this has sort of dominated the entire meta. It's like what everyone realized, that having a mitochondria was useful. And it's just everywhere now. It's kind of boring to watch, which is why people don't really like it. But my thought is that, Blizzard, the company that makes Overwatch, did not somehow realize this was going to happen. They couldn't calculate what the best combination of characters is. And if you can't even do that for a video game, how can we hope to comprehend what we should do in the cyber domain, which is a weirdly similar problem? I don't feel like we even think about these things properly sometimes. So, recently I attended RSA, as many people did, and this is a view of the RSA Expo floor before everyone comes in and, makes a mess out of it. But it's fairly interesting to look around at all the different products, see what they're trying to sell this year as opposed to other years, see how people differentiate themselves against each other, because everyone's put a lot of time and energy into this stuff. Each one of these booths is like $100,000, and you staff it with 10 people, and you've spent another $100,000 just planning out what your message is. And so there's significant effort that went into this. This company convinced its employees to stand out in the rain and pretend to protest against, I wasn't sure what. This guy's holding a pair of scissors. Too many threats, too little time. I'm not sure, what she's advocating for or not advocating for. How many alerts can you respond to in one day? It's a good question. I don't know. None if you're out in the rain. And so, just trying to get a little bit of ground reality. I went to there's a little booth behind here. I don't know if you can see it. It's the HackerOne free coffee booth where all their salespeople are. And I like coffee. So I hung out there for a bit, and I was like, hey guys, your main competitor's name is Synac. What is a Synac? And none of them knew, which I found very embarrassing. And if you go over to the Synac booth, like, they're like, I'm not real sure, but let me ask like the one technical guy there who did in fact know, so that was good. Honestly, I found the Synac people were pretty honest about their business plan. So if we look, we're trying to find like data through the noise is realistically what it is, and that takes a lot of work. And I found this was the most RSA booth of all the RSA booths. I felt like this really gathered the zeitgeist. Zeitgeist? I don't know how to pronounce anything, and I'm not German. It captured it into its cyber ultra brain. The thing about this is that as much as like you could make fun of this, I'm not really being ironic. This is enlightened, individualized security power against unpredictable threats. That sums up RSA better than any of the other $1 million marketing campaigns could have. And part of it was walking around, looking at all the products on the market now, and asking ourselves, what is different now from 16 years ago when we started this entire journey? Like you can take the talks, the hundreds of thousands of people in a room clapping at basically irrelevant keynotes that someone paid, upwards of $50,000 to $100,000 for, the parties where everyone's a security leader, kind of like everyone's above average in Garrison Keillor's monologues, the amazing marketing, like look at that entrance to this party. I mean, imagine how smart you have to be to get into that party. And then of course the booths and all the new discussions about product lines people are announcing, where they're positioning them, the new innovations coming from small businesses that have been funded by VCs. Take all that, mush it all up in this very particular machine, and then what you'll get is pretty similar architectures, right? You'll get a kernel telemetry gatherer that's gathering stuff out of the operating system that for some reason the operating system vendor doesn't want to give you in a clean way. Like, there really should be no reason for CrowdStrike, Endgame, Microsoft, and like 1,000 other people to all have their own kernel telemetry gatherer on Windows. That should realistically just be an API in Windows that is performant and gives you everything you need. It's a bizarre thing, and the same thing's true for Google's OSs or iPhones, all this stuff. This should be a feature of operating systems, the ability to gather telemetry in a secure way. But nonetheless, everyone's got their own extremely great kernel telemetry gatherer. You then have data storage and indexing, which is all very similar, and it goes into a machine learning pile, also pretty similar. That goes to a SOC, and of course you have that SOC going to this user interface so you can do the thing. This is a lot of vendors right now. This is like the majority of, I would call this last year's model more than this year's model, because this year was more about zero trust. But this was really super common, super powerful in terms of business market presence. And so what you start thinking is like, what are the themes that I'm seeing on the floor and just in general in the market? And one of them, and this is from 2018, is that Dino mentioned you buy security products for their APIs and not for their consoles, which is a very hard thing to say. Really, I buy security products because of what they don't do yet, is something that I thought was interesting. So, one of the advantages of joining Sixtera is that we got access to a lot of technology from our sister and brother companies. I don't know, sibling companies? I'm not sure. I guess company is feminine, so sister companies. And one of them is BrainSpace, which does big data analysis and visualization. And it really made a huge impact on the e-discovery market. But if you think about it, absorbing a mail spool and being able to really dig into it is very similar to absorbing a lot of other different kinds of information. So here's Ishan. He's doing his data analysis, and then I'm like, Zishan, you need to do this in a better way. Use the API. So you need to be a Python programmer and not just a subject matter expert, right? So here's some of the things that we want to pull out, but we want to pull them out automatically, not via you clicking around. So in a sense, Dino was right. And then if I do the same thing and I take like a VPN administrator and I make them a programmer, then that's what zero trust is to me, right? They're like, we're gonna deploy a VPN or a firewall access control thing, but I need it to integrate with, for example, ServiceNow, so that I can say, only when you have a ticket to a particular machine in production are you able to even reach that machine from where you are. So I think that like some of these things, you're like, what's happening realistically is someone programmed some JavaScript to connect to another API to make all these decisions in a contextually aware way, which I thought, coming from someone who'd never really dealt with access control at this level was kind of interesting. I'm like, well, you're taking administrators and IT people, and in a sense, you're saying programming is a core part of your feature set. And the same thing's true, and I think even more true with just the general idea of threat hunting. I find threat hunting mystifying. It mystifies me. And maybe it shouldn't. But let's say I take and I just stole a bunch of screenshots from the internet, right? So here's a bunch of anomalies. There's like 4.5 of them. And then here's the kind of queries that we're going to be doing. And let me just point out that anytime you see something like file name is greater than, which I assume means in some bizarre syntax, PowerShell, but also PowerShell capital, but also PowerShell ISE.exe, but also capitalized, like that's a broken language, right? Like that is bad. And I know they did their best. This is Microsoft's ATP. But at a certain point, what you're saying is we are just building technical debt. Just our language is just technical debt, and we're going to make sure that you know it right when you see our first example on our first website, right? Like this is silly. And they can prove that to you by giving you best practices that assume you're some kind of wizard for their proprietary database, right? So like they're like, it might be kind of slow because scale is really hard. So what if instead of joining two tables with more, you have to like, this is just a crazy, like there's no such thing as a unique process ID in Windows. Why not? You control the whole stack, the entire stack. Every process should have a GUID. It's so bizarre. So anyway, I don't think the T in ATP is what they meant. Same thing's true though, in a sense. Everyone's running into the same issues, right? So here's endgames. They're like, what if you had an event and we built this query language for you, and you went into the query language and you looked all around and you could save queries and analyze, like this is fascinating to me. What if our threat hunter was a programmer? Again, same thing in Splunk, right? So Splunk threat hunting is the same basic theory, and they're like starting to pay off by reducing from 234 to 176. And I've done like analysis of network stuff before. Lots of us have, and I think if you do like 3 a day, you had a pretty good day. You know what I mean? Like if you really delve into stuff at a deep level, then I think like the scale that you can reach with some of these systems, you're either like massively false negativing your whole subset, or you're just not getting the job done. It's kind of like what's happening here. And again, the same thing's true for fixing things. You're like, some of these programs, they look amazing for me to use because I am a Python programmer. So like something like this, I'd be like, this is awesome. I can control everything. But if your IT administration team is not Python programmers, then like, you're stuck using the GUI. You're kind of overpaying in a way, right? Like I'm paying for all of this API power and a very light GUI on top of that. But in most cases, the GUI realistically is just another program written on top of the API. And so another trap I see everyone falling into is like, what if instead of Python, we taught people a special language that just only for this problem, which would be optimized for this problem and for how we handle scale in this problem, which is kind of what SQL and EQL and all those things are. And I think most of the time you need to pull stuff back and then integrate it with other things and then do real programming. They just don't work long term. It's kind of funny to me when people invest tons in it. And so what I realized was that there's a difference between defense and offense in terms of how they are handling the meta. If you're like, why? We've built all these amazing things, right? So one question, I walked through all of RSA and stuff, and I was like, if all the marketing claims happened properly, and if even a 1/10 of the marketing claims happened, then no hacking would ever work because there's so many new innovations on defense. But if you think about like all of RSA is really about intelligent automation, and by intelligence they mean a human, then everything they're doing is requiring more and more programmers. But in offense, when I do intelligent automation, I realistically mean a program. Like I'm building just a thing that goes and does automatic stuff. I can let loose, and maybe that's because I'm not as risk averse when it's not my network. I'm not sure what the answer is, but definitely there's a difference in how offense and defense are thinking about this stuff. And so, if you want to win in defense, if you want to catch up to the offense, you have to ask yourself all the time, how can I just entirely take humans out of this process? That's the question you need to ask yourself. And the other issue that I've seen is a lack of, I don't know what the right word is, but almost mental scale, right? So if we take like Donald Rumsfeld's famous quote, he's like, and I don't know those of you who did logic puzzles as kids, but it's sort of like, binary, 1 and 0 here, you got known knowns, and then you have known unknowns, and then you have unknown unknowns, and that leaves you with one box left, the unknown knowns, right? So it's the things you don't know that you actually do know. Hopefully that made sense to your brain. Seems logical, right? So, for example, if you look at like the most modern, top of the line static analysis software that's available, all of them, they're all very similar in a sense. They do taint and sink analysis. They're like, here's a problem, and then in the code, you're like, here's where SQL injection could happen, and then here's where user input could go in, and if I can reach the SQL injection from the user input, that's an alert, right? And so, you can optimize over that problem by doing better data analysis or a bunch of different things. But what if we told you that taint and sink analysis cannot find the bug classes that good hackers find today, right? Like this whole process, while working better and better and better over time, maybe doesn't cover the bug classes that are important. And that's what I see in defense, is that I see that nobody has their aperture set wide enough to see sort of new bug classes properly. Like they see these little instances of them, and then they just assume they're one-offs, or they're like kind of similar to something else. They don't see the clustering. And so part of that's because most people don't have a ton of data, right? Defense people are focused on what they have right in front of them. Like, it's what's in my trough. Like, what's causing me the most pain? Where am I making my income? Where's my return on investment, right? Like, if I can get rid of 50% of the vulnerabilities on my network, I'm doing a good job, even if I'm completely unable to handle 10% of them long term, right? So, just to pick on the Microsoft team, because they're nice people, the Microsoft team is focused on Microsoft stuff, right? So if something's really common on Apache and PHP, they're not really gonna spend a whole ton of time looking at it, even if something that they have correlates with one of those bugs. Or maybe they're not that focused on iOS, for example. And I used to see this all the time with .NET programmers wouldn't look at Java advisories, even though they were very highly correlated. And the same thing's true about not being able to do deep analysis, because to do a lot of this work, you need a ton of time. And what you see is if you're on offense and it's an O day, then you have all the time in the world to really dig into the bug. How do I exploit this thing? Where does it exist in the world? What does it connect to? What is it like? Oh no, it didn't work when I tried it. Let me see if I can fix it. So that's not really true in defense, because the return on investment is just completely askew from that. And then, of course, people get invested in mitigation toolkits, like WAFs. Like if you have a WAF, then maybe you can solve all problems with WAFs. I think there's a lot of those things which, even though they produced a little bit of value in the beginning, when you try to spread their value out to all sorts of other bug classes, you really get like insanely diminishing returns, and WAF is a perfect example because the diminishing returns are it's a humongously deep slope, right? So if you look at like the universe as a whole, you can start to see filaments of matter all being connected, and that lets you discover functions related to dark matter and dark energy that the defense can't do because they're looking at a much smaller scope. So they don't even see the fundamental forces, is realistically what I'm trying to say. And I just want to give you an example of like, there's a ton of work that went into like discovering all of Spectre and all the like speculative execution stuff, all the information leaks from any of that stuff. And the real message in Spectre and in a bunch of these sorts of things, the other one obviously is Rowhammer, is not that speculative execution is dangerous, but that physics is super hard when you have like hundreds of watts going through something the size of a human hair, and hardware can't be relied upon. And there's reasons for that. And the reason Halvar quite well said in one of his keynotes was the hardware maker has a financial incentive to ship literally the most unreliable CPU that you can't detect as unreliable. And what that means is CPUs will always be subject to active attack, which I think is because that's not what's detected from testing. What's detected from testing is reliability, not security, which I think was a sort of fast. I mean, they're linked, obviously, but they're not the same in a sense the way people think they are. And so that feeds us into this sort of inability to really react to ODE. We don't react to ODE in a sensible fashion, right? So 100 years ago, we used to all use SSL VPNs, and they made no sense at the time if you understood how like browsers worked. And then no one cared. Everyone just bought them and built them until CERT said, hey, these operate in a fundamental way that is completely broken with browser security mechanisms. Like they're not good in any way. Terrible idea, right? So now you don't see these products anymore because you always have to have a client. So even when you have what's called an SSL VPN these days, realistically what they mean is browser plugin, which is a much safer way to do that sort of thing. So these are sort of it's fascinating that it went that far. And the same thing is true with, I think, more recent examples. Like this is a talk that was given at Infiltrate like in 3 years ago from Microsoft's research team. And what they pointed out was that Active Directory can be traversed and automatically exploited by software agents in a way that human beings find very difficult to understand or may never understand. And so these sorts of, like how Active Directory works and how it sort of forces vulnerabilities upon you, filter out people keep seeing these things and they don't realize the problem is the actual structure of Active Directory. It's how it's kind of thing. And the only way to really sort of get better at this is to spend a lot of time looking at vulnerabilities and trying to connect them to other vulnerabilities and thinking about the metagame in a deeper fashion. So when I look at when I look at the lineups for conferences, I actually spend a lot of time watching talks for conferences, all conferences, RSA, everything, because everyone's releasing all of their information. I like to think of it as like, if I had to hack this information out of those companies, would it be worth my time? And the answer is yeah. If I had to find out, a Solaris ODE that's never been out before, that can tell me a lot about platforms I used to rely on and the security of those organizations. So, I mean, it can guide your actions. Let it guide your actions. Let the force guide your actions, we say. Native client security contest, I always come back to this because I found it really funny. Native client, I don't think the security of native client went one way or the other in terms of decision making on whether or not the technology succeeded, but you do see people doing things that require the browser to be extremely secure, right? Like, why is this in the browser and not just a new Steam or Epic client or something? I'm sure there's a business reason, but it may end up having massive security ramifications. And that's what attackers really look for, which is they don't want to beat your technology. They'd rather beat your software design, like secure design lifecycle, right? The whole thing. I'd like to be better at secure design than you are, is how attackers think. And just to bring back to some of these larger pictures, CVSS, which takes any vulnerability and then scores it from, I guess, 0 to 10, and on a like with one digit, so it's like got one decimal point of discernment. And recently, again, CERT was like, hey man, I think this thing might be fundamentally broken and we should look at that. And I was like, you know what? I don't know. Because we use CVSS as part of our consulting practice. When we go and talk to a bank and we have a vulnerability, we rank it. We're like, hey, this is the following level of risk. We're switching from CVSS 2 to CVSS 3. And oddly enough, that raises all the numbers because CVSS 3 is generally higher, and that makes people unhappy. So then they want to stick with CVSS 2, which I think is like hilarious. But so I was like, you know what? Let's go to first.org, which is a well-known incident response. They are literally the first incident response organization, sort of during their conferences and everything. And it's a good group. All the certs are on it. And so you say, all right, let's take their very first example of how you do CVSS 3 scoring. And so you can go to this page and they'll talk you through it. And the very first red flag that I saw was this HTTP only thing, because HTTP only does not affect the impact of cross-site scripting normally. And I was like, that looks fishy to me. But we have junior penetration testers, and one of them had like a couple days free. And then I was like, hey, can you please look into this so that we can get the straight dope? Right? I was like, let's install this thing. Let's write an exploit for it. Let's see what the story is. So he installs it, and then we write a big blog post about the whole process. So they say, and here you can see it, like CVSS 3 is a base score of 6.1. And I'm like, you know what? What CVSS would claim is that any like legitimate, reasonable person will come up with the exact same score for a given vulnerability, because you can see how they did it. That's what CVSS is about. So we wrote this big blog post. I highly recommend you read the whole thing, because it just goes through how you would exploit a vulnerability, which is interesting. And what he says is that in the case when it's exploitable, then it would actually be an 8 in CVSS 3. So they underscored it by a lot, right? So they underscored it by 2 points, which is pretty big. And then the reality of this vulnerability is that it's not exploitable. It's not a vulnerability. It has a CVSS 3.0 score of 0, which is an even bigger error margin. And I think if you are not properly triaging vulnerabilities, if I, as an attacker, can understand you, as I can say, all of these vulnerabilities, all the cross-site vulnerabilities you've ever looked at are in fact 1,000 times more interesting than you think they are, then I can defeat your incident response process by simply focusing my attacks in that area. And so there's a lot here that I found very interesting in terms of what is the real danger of having broken metrics. And hopefully that's something that is self-evident. So how do you build world-class security defenses? How do I actually do this right? And what I want to point out is you can just think, what is the counter? Right? Like I have these indications of compromise, I have YARA rules, I have endpoint protection, I have network anomaly detection. What is the counter that an attacker is naturally going to do? And if I'm not detecting that counter, is it because it's just not being used, or because I just can't see that sort of thing? Right? Like if I can't detect oxygen on remote planets because I don't have the right telescope, then it's not my fault that I don't know that there's life on foreign planets. And then if you look at how your incident response team behaves, it's less about how they handle a new bug and more about how they handle a new class of bug. Like everyone, like new things, new big things, right? So Twitter phishing. Do you have any grasp on that? Probably not. Firmware implants. I don't know anyone who has any real grasp on that. Deserialization vulns. It's like all of a sudden every app within your Java like middleware needs to get looked at. Did you have a plan for that when those came out? Probably not, right? So how do I change my business processes if I have to is a question that I find is very difficult for large organizations and small organizations too. And then how do I decommission or de-architect just a class of product? Can I move off of Exchange to Gmail if I have to, right? Like what would realistically have to be done to do that? Like we had a lot of our banking customers, the instant that Kaspersky stuff came out, they were like, we need to look through our entire network, find Kaspersky stuff, and tell us where it is so we can decommission it. And that includes third-party products, right? So that means all their vendors who had included Kaspersky as one of the AV engines got a ping and said, we need a new version, but in 30 days that does not have Kaspersky software on it anywhere, right? Like this is how they have to react when they're really thinking about their security. And again, it doesn't have to be Kaspersky. I'm not saying Kaspersky is bad. I'm saying that that's simply the kind of behavior that you need to be able to take. Again, how do you handle unpredictable threats, but without enlightening individuals? Because if I have to rely on enlightened individuals, then I'm in a tough spot. I think I'm in a tough spot, and I think so. This is the answer to why do the products at RSA not just solve our problems, which is one of the questions that I was definitely asking myself, and I think a lot of people were asking themselves. And I'd like to finish up with a couple invitations. So I'd like to invite people to Sixteracon, which is, I believe, free, and gets you into eMerge as well, I think, if you come to Sixteracon. And then also Infiltrate, which is not free at all, and is definitely worth it though. And so, this is something that I think a lot of people don't realize is a resource right here in Miami that can help get you to some of these levels. So that's what I have, and hopefully people liked it, and I stayed within my time frame, which I think I did. Thank you.